I'm here to talk about Amazon's offering Bedrock AgentCore, and we'll deep dive on memory stuff specifically. And my name is Srinivas Nalagada. I'm a senior startup solutions architect. I work with a lot of healthcare life sciences startups within the Bay Area. So while we get into some of these details, I wanted to talk about little about the evolution of agentic AI, right? So it's been just fascinating to see how GenAI has evolved in the agentic AI space. In the first wave here, GenAI was used for simple content generation. You give it a prompt, it gives you an output, a paragraph, an image, a line of code, etc. Then we kind of saw the emergence of early agents that leverage reasoning frameworks, right? And then access and learn from proprietary information and data sources, and integrate with APIs to take actions via function calling and so on and so forth. However, over the last year, we've started seeing agents transition into fully autonomous multi-agent systems that can seamlessly kind of execute multi-step workflows dynamically, right? Adapting to the changing environments that we have. As a result, they're now capable of tackling far more complex real-world use cases like autonomously diagnosing and remediating IT production issues, perhaps, or even generate and deploy full stack applications from a single prompt, right? This leap in agents capability is driven by some fundamental shifts. Now, some of the Gartner research that we've collected says, about 33% of enterprise software apps will include agentic AI by 2028, up from less than 1% a couple of years ago, right? And he also Gartner predicts 15% of day-to-day work decisions will be made autonomously through agentic AI by 2028. Before we get into the actual service itself, I want to talk about some use cases that we see across the industry, right? Agentic use cases in automotive, energy, financial services, healthcare, life sciences, media, and entertainment. I'd like to take a pause here and see if you have any questions around what do you see, any interesting stories in the crowd. Cool. We'll talk about these in detail. So to introduce you, Amazon Bedrock AgentCore is a platform where you can build and deploy and operate highly capable agents securely at scale using any framework or model. We do the underlying undifferentiated heavy lifting for you. So we provide you with a set of modular services that you can mix and match with everything you need to get agents production ready, right? You have a runtime modular, memory, which you're going to double click in a bit, identity access management, gateways, code integrators, so on and so forth. Now, this picture kind of gives you a block view of all the modular services that I just showed on the previous slide. You need enhancing with tools in memory. How do you deploy securely at scale? And also getting like operational insights with agentic operations, right? Along with all of this, we've also baked in observability and security into this AgentCore platform. Now, what is actually needed to build a context-aware AI agents, right? The answer is simple. Agents need memory. Now, let's look at a couple of scenarios here. Agents without memory on the left-hand side and agents with memory enabled. Users interacting with agents, you get a response, but response without previous context, right? Now, if you have memory, you're writing the agents with the context of the memory, and responses come with contextual awareness. Every time you have a new conversation, it retains the context. Here's an example, right? I like this quote which says, an AI agent without memory is like a goldfish. Because essentially, if you look at this chat, the user says, how do I switch apps on my iPhone? The chatbot replied saying, what is the iPhone model that you're using? iPhone 16. Try this link. It has all the gestures to switch between apps. This was on June 1st, 2025. June 3rd, 2025, how do I take a screenshot on my phone? What is the iPhone model you're using, right? We want to get from here past that, right? Loss of context does not give you personalized user experience. Now, what we want to do is don't just remember, be smart, have contextual intelligence, have user preferences stored, and also have knowledge retention, right? We'll double click a little bit more on these. For agentic memory, the core concepts are broken down into two segments. One is the short-term memory, and one is the long-term memory. While short-term memory functions like RAM in a computer, temporary, session-based, long-term memory acts more like a hard drive, right? Persistent evolutionary learning. This dual memory architecture enables both immediate responsiveness and sustained improvement over time, respectively. Long-term memory is crucial for enabling AI self-evolution, where models and agents can continuously learn, adapt, and refine their reasoning and capabilities based on accumulated experiences, right? By incorporating long-term memory, AI agents become more like adaptive teammates, capable of building on past experiences to provide increasingly valuable and intelligent interactions. Now, if we go back to the short-term memory question, right, this is what we want to achieve. If I ask, how do I take a screenshot on my phone? Read this guide on taking screenshots on my phone. So what's happening here is it's staying present, not just recalling words, but following your thoughts. It recognizes what you're trying to accomplish right now, picks up exactly where you left off, and also keeps recent insights accessible, right? Treats your uploads as part of the conversation. Now, for long-term memory, right? Here's the interesting part. So I want to make a purchase. I like Bose headphones. My company gives me 25% discount. I prefer, they don't, but that's an example. My company gives 35% discount, and then I prefer white open ear headphones, right? Now, what it understands is user preferences and memory, right? Likes Bose headphones and also likes the color white. Stores like what users likes, prefers, buys, gets updated over time. I want new headphones to change the old ones. It's checking memory and it responds, hey, I can suggest some wide open ear replacement options under $300 to would fit your budget, etc. So that's what we want to achieve, right? Some repetitive slides here, which I want to skip. So so the whole context of these slides is to kind of emphasize that memory is being stored and used as part of whenever relevant within the conversation. So while Amazon has been building this service, we did see a lot of challenges that come from the market, especially about how do you, storage scalability issues, how do I refresh the memory, how do I integrate with 40 different systems that we have, privacy, which is day zero concern for AWS privacy and security, what are my retrieval options and observability on top of everything, right? So while solving this, let's click on Bedrock AgentCore memory now. Here, the core infrastructure is serverless with minimal setup. Like I mentioned, we do the underlying undifferentiated heavy lifting, so you don't have to manage all of your infrastructure. There's built-in encryption enabled, flexible time to live, and observability. Same thing with memory management. You have options for short-term and long-term, built-in memory consolidation, one API to store multiple messages as one interaction, right? Same thing with memory extraction options, summary per session, user preferences, semantic memory to understand the context meaningfully, and then multiple retrieval patterns, right? Now, a little bit in a modular section about high-level overview. You have agents feeding in raw events, short-term memory. You have a memory extraction module. This is pretty similar to how machine operates. And you have memory records being stored in a long-term vector store, which are retrieved back as memories. Short-term raw storage. we want to double click on this. So when the agent is implemented, you have conversational log JSONs. Now within the agent memory, you sync chat messages, session state, and checkpoint, while also syncing all the list events. Now, here I want to break down a little bit of how these entities operate together for short-term memory, right? Event is a collection of messages who they belong to an actor ID, organized and separate accordingly to group the events and maintain context. Now, here's an example, right? I want the event expiry days to be 7. So let's just say that you have a conversational chatbot in front of an e-commerce website, and I'm trying to buy Bose headphones. Day 1, I ask questions. Day 4, I come back and I complete my purchase. It still retains my context. This is something you can set up during configurations based on your use cases. I have a few more examples of how we can configure this. I will also share a QR code for this deck where you can actually double click and look at this. So for long-term memory, right, section summaries creates condensed representation of interaction content outcomes. Same thing with namespaces. Folks familiar with AWS will understand you'll need an ARN permissions to be granted. Earlier in one of my decks, I presented this modular approach about AgentCore, right? One of them is identity. What we try to achieve is for fine-grained access controls, if you have identity and access management defined at your org level, all of these translate into your Bedrock AgentCore service as well. So you don't have to redefine fine-grained access. Now, I want to show you a couple of diagrams in the interest of time. Before we get into the couple of architecture examples, I want to showcase the observability concept of this. So, like I mentioned, you can capture all your CloudWatch logs for the way these agents and the memory is behaving. So this kind of gives you the overall observability, and you can build on top of that as a feedback loop. In terms of security, like I mentioned just now, you can have identity access management where you have a basic IAM policy for short-term and long-term memory, or you can implement fine-grained access controls, secure multi-user or multi-session memory management within AgentCore memory. Couple of example architectures I wanted to showcase for short-term. I'll leave this for a second if you want to click pictures. User question agent responses. So you have your local environment. I didn't realize there's a touch screen. Local agents, you could use trans agents, store conversational history within AgentCore's memory. And then you could use Bedrock's offerings of LLMs that we have. You could choose the model of your choice by evaluation, and then work with it. For long-term, similarly, like I mentioned, long-term memory is stored in the vector database, and then there are multiple choices of vectors, vector database you can pick from. Again, invoking a model of your choice within Bedrock. So a couple of decks here. We have some AWS code samples available on GitHub, and also the deck where you can actually look at multiple options that are available. Thank you.